Okay, so we're going to have a look at implicit differentiation today. And the idea is some curves cannot be solved explicitly for one variable. Right? You can't necessarily solve for them. They might not be functions at all, like the circle. It's not passing the vertical line test. But you still could ask questions about, like, what the tangent line to the curve at a certain point might be. So, however, we still might be interested in the slope of the tangent line to these curves. And so we can accomplish this by thinking of one variable as an implicit function of the other. So basically, this means that whenever you try to do the derivative, if you did the derivative of a function, you would take the derivative of that thing, then you would also multiply by some f prime of x. So we're going to do the same thing essentially with like y and x. So let me show you how to do this with just a simple example. So consider the equation of the circle centered at 0, 0 with radius 5. So that is the equation x squared plus y squared equals 25. And what we want to do is find the equation of the tangent line to the circle at the point 3, 4. So it's not so easy to solve for y in that equation. You'd have to have some plus or minus square root stuff, and that would make the derivative more complicated. So the idea here is we're going to think of y as an implicit function of x. So what we do is we take the equation x squared plus y squared equals 25, and we're going to differentiate both sides. So we differentiate both sides of the equation. Differentiating 25 just gives 0. But when we differentiate x squared, okay, that's just like normal. That would be 2x. But then when you differentiate y squared, what you do is you do the derivative as normal. So it would be 2y. And then we multiply by y prime. That's going to be an implicit function of x. So that's 2y times this derivative of whatever that function happens to be. So then what we can do is we can solve for y prime. So we start by subtracting 2x from both sides. So we have 2y times y prime equals minus 2x, and then divide on both sides by 2y to get y prime by itself. So now y prime is by itself. The 2's cancel, and this is equal to minus x over y. So this is essentially our derivative function for that circle. So what we do is we plug in that point that we had 3, 4, 3 for x and 4 for y. So the slope of the tangent line at 3, 4 is negative 3 divided by 4. Okay, so we have the slope. Now we want to find the equation of the line. You can just use point slope form to do that. So y minus 4 is equal to negative 3/4 times x minus 3. And this is the equation of the tangent line. So this is the equation of the tangent line. And if you want, we could graph it to see. It's always, we say it's tangent at that point. Let's go ahead and see it. So let's go to desmos.com. We just want to graph it. So we have our circle, x squared plus y squared equals 25. And then we have y minus 4 equals minus 3/4 times x minus 3. And we see it's perfectly tangent at that point 3, 4. So that's exactly the equation of the tangent line that we found. So pretty neat. But the main part here of this is this derivative idea, how to think of one function as an implicit function of another and solve for the derivative. And that was where we didn't even first have y solved for. So let's go ahead and find another tangent line. This one is technically to a curve called the folium of Descartes. So let's say A, find y prime if x cubed plus y cubed equals 6xy. So this is going to be interesting because we're going to have to use the product rule there. And then B, find the tangent line at 3, 3. So very similar to the last question. Okay, so for part A, we start by, again, taking the derivative of both sides. We're thinking of y prime, or y is the implicit function of x again. So we want to take the derivative of both sides. So the left is pretty easy. The derivative of x cubed is going to be 3x squared. And then the derivative of y cubed is 3y squared times y prime. Anytime you take the derivative of something involving a y, there's going to be a y prime. For the right-hand side, we need a product rule. So product rule for the right side. Let's just say u is 6x and v is y. Then that means u prime is 6 and v prime is going to be y prime. The derivative of y is not 1, it's y prime. So then we multiply. So u prime v plus uv prime, we get 6y and then plus 6xy prime. Okay, so this is the part that always tricks people. We want to solve for y prime. So the way you solve for y prime is you get all the y primes on the same side and then you factor. So what I'm going to do is I'm going to subtract 6y and then also subtract 3y squared y prime on both sides. And what that is going to do is it's going to move the 6y to the left and it's going to move the other term with the y prime to the right. notice you have two terms that contain a y prime term and two terms that do not. So we end up with just 3x squared minus 6y on the left, and then we have our 6x y prime minus 3y squared y prime on the right. So what you can do now is you can factor out the y prime on the right. Again, sometimes the implicit differentiation might give us derivatives that look a little bit messy, and they typically involve two variables, but it allows us to find derivatives that otherwise we typically would not be able to find. So we have 3x squared minus 6y, and then we want to factor out a y prime, so we have 6y minus 3y squared, and then the y prime on the outside. And then we just want to divide on both sides by this 6x minus 3y squared. So now we have our derivative. So 3x squared minus 6y over 6x minus 3y squared. This is y prime. That's our derivative. So that's the answer to part A. For part B, we're trying to find the tangent line at the point 3, 3. So the first thing to do is to find the slope. So our slope we get by plugging 3 in for x and 3 in for y in our slope formula right here. So we get 3 times 3 squared minus 6 times 3 over 6 times 3 minus 3 times 3 squared. So this is 27 minus 18 divided by 18 minus 27. So we get 9 over negative 9, which is negative 1. So then we just need to find the tangent line, right? So the tangent line again would be y minus 3, and that's going to be our slope, negative 1 times x minus 3. And this is the equation of the tangent line. And again, we can go back and take a look at the graph, see what this actually looks like, the folium of Descartes and the tangent line. So let's hop back over to the graphic calculator. So this time, our curve, we have x cubed plus y cubed equals 6xy. So nice little loop. And then our tangent line was y minus 3 equals negative 1 times x minus 3. And we see it's exactly tangent at the top of that little loop there. Okay, so let's go ahead and look at a couple more examples to practice this implicit differentiation. Like I said, I think something like, well, I don't know if I previewed this or not. If we look at our homework that's due on Friday, I don't know how many implicit examples we have. So we have just regular chain rule derivatives and product rule derivatives and things like that. We already did part 1 of the homework, so the last ones we have to look at are just 11 through 15. So we have 5 implicit differentiation problems at the end. And you'll notice number 14 and 15 both are finding a tangent line, and you've got some nice curves as well. Notice again that these things are typically not functions. They don't pass the vertical line test, but we can still talk about tangent lines at certain points. We just need 2 coordinates because the derivatives are involving x and y. So yeah, let's go ahead and just do a few more examples where we're finding some implicit derivatives. So let me do a couple, then I'll give you a few to do. So let's say find y prime by implicit differentiation. So A, let's go ahead and say we have, let's say x squared minus 2xy plus y cubed equals 13. Again, the x squared and y cubed are going to be pretty easy to differentiate, but this middle guy involves a product rule. So anytime you have y times an x, there's going to be a product rule. So again, what we do is we just differentiate both sides, and a lot of times you can maybe skip this step where you just say you're taking the derivative, but I'm just going to do it now. So we have 2x, and then, okay, let's think about the product rule. So I would say u is minus 2x, v is y, so u prime is minus 2, and v prime is y prime. So I would have minus 2x y prime minus 2y, and then we take the derivative of y cubed, which is going to be 3y squared y prime, and then the derivative of 13 is just 0. It's just a constant. So again, we've got 4 terms, and the 2 we want to keep on the left are the 2x minus 2x y prime and the 3y squared y prime, because those both have y prime in them, so that's how we're going to factor it out. So we'll subtract a 2x and we'll add a 2y to both sides, so that way we're adding, moving the terms that do not contain a y prime to the right. So I have 3y squared y prime and a minus 2x y prime, and then a 2y minus a 2x. And then I can go ahead and factor out y prime. So I have 3y squared minus 2x times y prime, and this is 2y minus 2x. And then that's all you have to do is divide. So a lot of times you might end up with a big messy derivative, but it really just amounts to factoring and then dividing. So our derivative here is 2y minus 2x. I wrote the wrong term first. 2y minus 2x, and then over the 3y squared minus 2x. And that's it. So that would be your derivative. So that's all you have to do for this one. Let's go ahead and do another one maybe. How about we involve an exponential? So I'm not sure how tricky this will be, but it's one of the exercises from the book. Let's say we have e to the x squared y, and this is equal to x plus y. So the right-hand side's pretty easy when you take the derivative. The left-hand side is going to be a chain rule, though. So let's go ahead and take the derivative of the right-hand side because we know how to do that. The derivative of x is going to be 1, and the derivative of y is going to be y prime. On the left-hand side, though, we have a chain rule, right? So how do we do the chain rule? Well, we would say our inside function is x squared times y, and our outside function is e to the u. So the derivative of our outside function is still e to the u. And the derivative of the inside function, we need a product rule for. But we've done product rules similar to this several times now, so I'm just going to write down what it is. It's going to be 2xy plus x squared y prime. So our derivative on the left will be 2xy plus x squared y prime times e to the x squared y. So notice if u is x squared and v is y, then u prime is 2x. So we have u prime v, and then you would have u times v prime. The derivative of y would just be y prime. So the product rule is very straightforward there. Okay, but now there's a bit of an issue. We have a y prime term stuck inside parentheses here. So we want to collect all the y primes together, so we actually have to expand this. So we have to multiply e to the x squared y through. So if I do that, I have 2xy times e to the x squared y. plus e to the, sorry, I meant to write the x squared y prime first. So plus x squared y prime times e to the x squared y. And then we still just have our 1 plus y prime. So we want to, I'm going to move the y primes left and my other terms right? Essentially, there's 4 terms here. So 2xy e to the x squared y, I want to move that to the right because it does not have any y primes in it. So I'm going to subtract that on both sides. And then I'm also going to subtract y prime on both sides so that the y primes are both on the left. So I know this looks really messy, but really everything we're doing is exactly the same as we've done for the previous problems. We're just collecting the y primes and then factoring. But again, the derivative will look like a big old mess. So I just have 1 minus 2xy e to the x squared y. So I can factor out my y prime on the left. So I have x squared e to the x squared y minus 1 times y prime, and this will equal 1 minus 2xy e to the x squared y. So now that's all I have to do is divide, and y prime is solved for. So y prime is equal to 1 minus 2xy e to the x squared y over x squared e to the x squared y minus 1. So, I mean, a lot of steps. Really, this is about algebraic manipulation more than anything. So that's why these can sometimes seem a little bit tricky. But yeah, I would never ask one so challenging. But it's good to see them sometimes just to kind of see how difficult they can be. So yeah, that's the end of part B there. Maybe we'll try one more where we find a tangent line, but that's pretty much as much as we're going to get into these. It's a nice technique, like I said, for these other curves. Okay, so yeah, let's try one more tangent line problem. So example, let's say find the equation. And I'll give you guys a few minutes to try this one because it's going to be similar to the folium of Descartes problem we did. So find the tangent line to x squared plus xy plus y squared equals 3 at the point 1, 1. So you first want to do implicit differentiation to find y prime, and then after that you want to just use point slope form. So plug in 1, 1 to find your slope, and then use point slope form. So again, the derivatives are pretty easy. You just need to remember to use a product rule when you differentiate x, y. So why don't I give you 2 minutes to attempt this one at your own, and then we'll go ahead and walk through it together. Okay, so let's have a look. Hopefully you're able to get the derivative at least. So again, just start by differentiating both sides and thinking of y as an implicit function of x. So the derivative of the 3 is just going to be 0. The left-hand side, derivative of x squared, pretty easy, 2x. And then we need to use a product rule on x, y. So the derivative of x is 1, so we get y, and then we get x times the derivative of y, which is y prime. And then we take the derivative of y cubed, which will be 3y squared times y prime from the chain rule. So we want to move the 2x and the y to the right-hand side. So we have xy prime plus 3y squared y prime equals minus 2x minus y. And then we want to factor y prime out on the left-hand side. So we have x plus 3y squared times y prime, and this will equal minus 2x minus y. And so then y prime will be minus 2x minus y over x plus 3y squared. Okay, and then you plug in the point that they gave us, which was 1, 1 for the slope. So the slope is going to be negative 2 times 1 minus 1 over 1 plus 3 times 1 squared. So we get negative 3 over 4. That's our slope. And so the tangent line would just be, y minus 1 equals minus 3/4 times x minus 1. This is the tangent line. At 1, 1. We can go ahead and graph it just to check that out. Okay. So this one we had the x squared plus xy plus y squared equals 3. So we have this ellipse. And then we have our tangent line y minus 1 equals minus 3/4 times x minus 1. So we see its tangent. The point of tangent C is 1, 1 right here. Okay. Yeah, so that's probably going to be a good stopping point for us. As you can see, the ones at the end. So, sorry, this is Calc 2. The problems at the end here are all similar to what we've done today. So 11 implicit, 12 implicit, 13 implicit. 14, we just did that exact problem. So that one's done for you. Albeit I didn't realize we were doing it, but and then 15 is an asteroid problem, so it's a different one. So give those a try. The assignment's due Friday, and we'll use Friday's class to go over any homework questions you might have. Otherwise, we'll stop here for today, unless you have any other questions for me.